Okay, welcome to Quarkus Insights. I'll go directly into it. So, hello. Now I see viewers coming. So, guys, sorry, we seem to have started on the wrong view channel. Now we have it. Now it's counting up. So, guys, I'm back from vacation, and that's why I still can't know how to use a computer. So we're here with Geoffrey and Emmanuel. Geoffrey's going to talk about Optaplanner, and Optaplanner is one of those few things, well, not few things. It's one of those very special things I feel is very underrated that can be used for a lot of different things. And we actually made a podcast about it 5 years ago in 2015. I'll give you the link in the video, and I'll share that. If you want to know about the basic Optaplanner, like real basics and how it works and a lot of details, not a lot of detail, like a lot of overview, that's a good place to start. And today I hope we'll get to talk a bit more about how it works in Quarkus and maybe see some code too.
And just for people, because I'm just looking, and the Quarkus Insight on YouTube at least says that we're going to talk about Kafka streams. That's not the case. We're talking about Optaplanner. Sorry about that. Hey, it's April 1st. Welcome. This is cool too. So stay tuned. We're talking about solving problems in a systematic fashion.
Yep. So I might find a way to optimize Kafka streams also, maybe.
We'll get there. So anyway, Geoffrey, you want to a little bit about yourself and maybe what Optaplanner is?
Yeah. 14 years ago, I started a little hobby project, and that's now Optaplanner today. So it's used across the world. We're working on a serious team now, right? So and it's used for all kind of planning problems. So for example, you need to assign vehicles to routes to deliver a number of items across the country, or to restock stores. Vehicle routing problems are really everywhere. Or you're doing an employee rostering problem, assigning nurses to shifts, doctors to shifts, a cloud balancing problem, you're assigning processes to machines, or hardware to stacks and stuff like that. And all of these things suffer from constraints because you don't have unlimited time, you don't have unlimited budget, you don't have unlimited people. People can only work an extra number of hours a day. Vehicles can only be in one location at the same time. So basically the constraints of the universe, and then the constraints of the finances, the employee happiness, and of course the ecological footprint, right? And so we're going to, Optaplanner optimizes all of these. You basically say, I want to optimize these constraints. You throw them all in, and Optaplanner then finds the best possible solution it can find in available time for that case, right? And I'll show a few of those.
The cool thing about Optaplanner is that basically I can't think of any IT product that doesn't have a problem that Optaplanner could actually help with. It's just sometimes hard to express those and find them. But as I said, anything of layout, anything planning, anything that you have to fit something into something else is a traditional Optaplanner thing. Yeah.
By the way, one question, like how live is it? So when you say, nurses have to be, at the right time in the right place for, saving lives. So you could imagine something like that is anticipated by a week or even a day, worst case. So that's okay. I forgot if it was this or like the fourth run we started, but you also mentioned that bandwidth was something you could optimize. So that's more live, right? That's literally data ongoing. So
assigning nurses, for example, or doctors to shifts, you do that typically 6 weeks in advance or 4 weeks in advance, because they need to know, they need to plan their social lives, right? They need to know when they need to show up at the hospital. Sometimes it does change up to a day in advance, but not milliseconds or seconds, right? In other cases, satellite bandwidth scheduling, that one was actually most of the time it's also quite in advance, but for example, for vehicle routing, it can actually be on millisecond behavior. Think about it. FedEx is going out with a vehicle to pick up a number of items or any kind of other thing like that. And what they see is a customer calls in and says, okay, I want you to pick up this item. And they have vehicles that are about to pick up an item nearby. So at that point in time, you want to do something called real-time planning. And so yeah, we have that support for that real-time planning. It's one of our big features. I can't show you that on the Quarkus examples yet. We should probably add that. But we do have in our old swing examples, the ugly ones, we do show where you can in a few milliseconds update those. Even in 12 milliseconds, I've tested for like vehicle routing and so forth.
Okay. Does that mean it's an incremental engine?
Yeah, so there's two things that's incremental. So the first thing that's incremental is a score calculation, which is a bit hard. I can maybe explain later, but when we look at the constraints on how you solve the problem, maybe I should demo it first and then I can talk a bit more about that, incremental calculation. And then the other thing, the incremental part is indeed when we have a solution and the problem changes, like for example, a nurse calls in sick, a vehicle breaks down, we get a new customer, we need to send a new technician to particular location. Optaplanner actually can do a warm start from the existing solution, take that into account, it comes from an async thread, and actually react on that very quickly. Right?
Let's jump into the demo and see something. We can talk from there.
Yeah, sounds good. So I'll just directly jump into the demo. I'll start with the Quarkus facility location case. So we have a couple of demos in Quarkus already, and we're building more. So this is the facility location problem. So what is it? I'll be best if I just show you in the UI here. So this is a facility location problem. Can you guys see the screen?
Yes, we can.
Yeah, okay, great. So what we have here is we have the city of London, and we want to basically figure out where do we want to create a few bakeries or something like that, because we have a chain of, let's say, breakfast restaurants, right? Think something like Starbucks or something like that. Or we want to have 5G coverage here, and we need to place a number of masts and figure out make sure we have coverage across the entire city. Now, what we have is we have a number of locations where we can put them. These are these gray dots. And then we have the blue dots, in this case, to actually supply with a number of requests, right? So, for example, here we can put one. It has, you can put up to 170 requests there per minute or something like that, or per, croissants per day, whatever the case may be. But there's a setup cost, right? And so the setup cost differs from location to location, as you can imagine.
So what do you say the blue ones are?
The blue ones are the circles, they're no longer blue now, but that's are actually the consumers. So we want to figure out where do we place our facilities so they are closest to the consumers. That's basically the question, right? Do we want to place one facility and basically supply all consumers from that location? No, because then the distance is too long. So we want to put multiple facilities. So a facility could be, for example, a telco mast, right? That's one example. Or it could be a bakery for when you want to supply your those Starbucks stores or something like that. Or it could be a COVID test center, right? You want to have
I'm about to say that. COVID test center or a Lexington pallet somewhere.
Everywhere.
Yeah. And there's the cost, right? Everyone you want to put as little as possible there, because there's a huge cost of starting this up. At the same time, you want to make sure that you cover as many people as possible too, right? So and depending on your budget, you can maybe do more, put more or less, but and so here's a case. So here's an example. So what you see here is we have Optaplanner has chosen to set up about 8 facilities. You can see them here on the right. You can see how much they're used, and you can clearly see like this one is used 135 of 150 units that it produces. Right now, they're all producing 150 units, but you can imagine that on some if you have more space, you can test more people for COVID every day than in smaller locations, right? And you can see the cost of actually choosing these locations, right? Basically the real estate cost or the rental cost, right? And now it's been optimized. Now I want to show you something. What happens if we only go ahead?
Yeah, you say no, it's been optimized. So we've seen the blue stuff like just blinking like for several times until it stopped. So what happened?
Yeah, that's a good question. So in the end, Optaplanner takes a look in this case at 2 constraints. So let me show you those. So if I jump to the code here, there's 2 constraints in here. Actually 3 constraints. It's a facility capacity constraint, it's a setup cost, and the distance from facility, right? So the first one, the facility capacity constraint, that one makes sure that no facility has more people assigned to it, or more consumers assigned to it, or more stores assigned to it, or more census blocks assigned to it, whatever the case may be, than that it can handle, right? That it can produce, right? So the circles are the consumers, the dots here are the producers, right? So that's a hard constraint. That means, because if you can only test, let's say, 1,000 people per day in your COVID center, and you send 2,000 people a day there, that's not a good idea, right? So the other option, the other thing, is the setup cost. How much does it pay to rent? So let's take a look when we disable this, and this is Quarkus, so we can just press refresh, and we can push the solve button, and we can immediately see results of changing those constraints. I've just thrown out the setup cost. And so what basically now does, it for each and every location, it only optimizes on the capacity again, but there's plenty of capacity, as you can see, right? And it optimizes also on the distance from the consumer to the location. So you can see it pretty much always takes the nearest location for each of these, right? And some of these are not used.
That's why it was so fast, right? It's like the capacity was so high that finding a solution that was matching capacity, and it was just essentially one problem, which was finding the closest.
Yeah, and that's very, very easy. We can see that the cost of that is now about $1 million. So it might be a bit too high. So let's see if we
Boston's are not cheap, so
yeah. So if we go back here, and we go back to the original case, we can see that if we solve this one, that the cost is much lower. And this is the total cost, but then of course the total distance is a bit higher now. And now he's actually trying to find a win-win situation, right? Where we minimize the distance and also minimize the cost, right? And this is what we get, if that makes sense.
Yeah, very cool. By the way, I just want to mention too, if you have questions or want to say Optaplanner is awesome, please do so in the chat. Or if you have a problem, then do so. We will interject and ask Geoffrey about the right questions.
Yeah. So, by the way, actually, so Optaplanner, I was expecting this would be like a software I install and then I click on a UI, but it looks like you showed some Quarkus code. So how do I use that?
Yeah, sounds good. I'll switch to another example, the one we also have the Quarkus quick start for, the Quarkus guide for, which you can find on Quarkus.io itself. So I'll switch to the school timetabling example. So what I have here, this is a school timetabling example. I'm going to disable all of the constraints for now. And let me just see if I close this down. Yes, so I'm just going to Quarkus dev this one. So in this case, just as a quick introduction, what is the case? Let me just switch forward here. Is we have to assign a number of lessons to a room and to a time slot, right? So we have 4 lessons here, 4 slots to put them in, 2 rooms, 2 time slots. But we want to make sure that, for example, these 2 lessons, which have the same students, the 9th grade, are not happening at the same time. And these 2 lessons, chemistry and French, same teacher, not happening at the same time. And so we give them to Optaplanner, and Optaplanner will find us a solution for us, right? So meanwhile, let's take a look. So this is the solver, and you can see we have a number of unassigned lessons here, the biology, the chemistry, and so forth, teachers, grades, and here we have the slots to put them in. Now, what I've done is, I'll go through the code a bit in a bit.
So, Geoffrey, maybe to clarify, like the UI you're showing is a custom UI for that specific problem that you build up. Right? So it's not like Optaplanner comes with a UI auto place. It's something you build for the thing.
Yeah, it's actually a JavaScript UI, and which you can just find in this thing. Just similar like for the facility location problem, the ones I showed earlier, we also have one, right? So and you can embed Optaplanner in any Java application. And with Quarkus, we have the Quarkus extension that does a lot of the hard work for you. So I'll just take you through what you need if you work from Quarkus. So what you need is a domain, right? So we have a couple of classes here. We have the lesson class, which has an ID, a subject, a teacher, student group, right? So the subject could be math, the teacher could be Marie Curie, the student group could be 9th grade. And then we're going to tell them, you can see these are actually, we use Hibernate in here too, right? To store everything to the database. Of course, that's optional. The other example, for example, doesn't use Hibernate, just keeps it in memory. That's a little bit less, of course, when you close the application because you lose your state. But anyway, and then we have this planning variable thing. So this basically tells Optaplanner that this is what Optaplanner needs to change. It needs to assign each of these lessons to a time slot and to a room, right? So to just visualize it a bit with some domain model. So this is our architecture. We have Quarkus. We expose everything through, the REST Easy plugin. We go to a hibernated relational database, and then in the browser we have written some JavaScript in this particular case. Again, you could take out any of these components and throw something else in there and not go to a relational database, right? Typical thing you do with Quarkus.
So Jeff, we have a question from Jennifer about the example repository examples. These are just all the ones that are in the main Optaplanner examples folder in Optaplanner, right?
No, these are actually in the Optaplanner quick starts. So all the new ones are in the Optaplanner quick starts. And let me just show you. So if you go to optaplanner.org, and we will be moving the examples, which is our old swing examples, which we have many. We have 23 swing examples to here too. But the problem with those is that people love a web UI these days, right? So that's why we're doing more. And people want to see how do we integrate this with Hibernate and how do we integrate it with REST Easy and JSON and stuff like that. So that's why we're now focusing more on how to integrate the whole thing into the entire story. We even have a Kotlin version of the school timetabling version, but we have a plain Java version one too, of course, right? And by the way, I was very well surprised on how easy it was to code Quarkus.io to try the Kotlin stuff. Not that I prefer Java, but still it works very well. Anyway, okay. Cool. Jump back on the domain maybe. Let's take a look. So maybe I'll just run it first, and then I'll get back to the domain. I'll start with the domain, right? So what's the domain? So we have this lesson, like I showed earlier, subject, teacher, and student group, which we need to assign to a time slot and to a room. The time slot is a day of the week, Monday to Friday, has a start time and end time, and the room has a name, right? And you can see this is a many-to-one relationship. Every lesson needs to be assigned to one time slot, but multiple lessons can be assigned to the same time slot, but not in the same room at the same time, right? And so this is the most important thing you need to do for Optaplanner. You need to tell them, what is your planning variable? What can I change? So for Optaplanner, I cannot change the name of a teacher or something like that, right? It can only change which time slot and which room to assign it to, if that makes sense.
Yep.
So, and that's what we see also in the code. So we have, like I showed earlier, and those are those annotations here. And then I put everything together in a time slot class. I'll not go into much of these details. This is still boilerplate, I think, a little bit. We're trying to get rid of this class more. But basically, it gives us a list of all of the time slots, a list of all of the rooms and all of the lessons we need to assign. Right? Because we need to get that list of time slots, a list of rooms, and a list of lessons somewhere. That's usually quite straightforward to do. It's actually deciding what is the planning variable. That's a challenge for everybody. And then we have this constraint provider, which tells us what we shouldn't do. And what I've done here right now is I've actually disabled all of them. And what I would like to do is I would like to enable them one by one and show you the effects of enabling these constraints. So let's take a look.
Yep.
Yeah. So when I solve them with no constraints, guess what it does, right?
Everything on the first day. Awesome.
Yeah. Yeah, everything at the same time. So now the 9th grade have to watch, biology and chemistry and English. They all get the same lesson at the same time. It's a horrible thing, right? So if we jump back here into the code and we say, okay, that room conflict. Let's enable the room conflict, and let me show you how that code is written, right? So Emmanuel earlier he asked, do you have increment? Do you do something incrementally? And in fact, we do. You can write these constraints with for loops. It's called an easy Java score calculator. Let me maybe bring up the interface. And you can just say, give me your timetable, and I will give you a score for that. The score is basically two numbers: an int for the hard score and an int for the soft score in the simplest version, right? However, when you do it like this, it's not really fast. It's not incremental. So we figured out an API. This is relatively new. It's the constraints stream API, which allows you to write your constraints in a Java way, Under the hood, it uses rules, but you write it in a Java way. You write Java 8 functions in there, and it will do the incremental calculations for you. So when you, for example, say here, from unique pair, which says select any two pairs of different lessons, so any two lessons where they are in the same time slot, so they equal in time slot, and they equal in room, we're going to penalize that as one hard constraint. Does this make sense a bit?
Yes, let me rephrase. It says a lesson cannot be at the same time, and I mean, two lessons cannot be in the same time and is in the same room, and it's not like a preference. It's like it's not possible to find a solution that would compromise that.
Yeah. Yes, that's why it's a hard constraint. So and when we run this, so let me just see if I can. Yeah, I just added it. So when we just refresh this and we solve this now, right? Then what we'll see is that this looks like a much better schedule, right?
Looks more better,
yeah. Yeah. Except, of course, so this is by room, right? So you can see there's never two lessons in the same room at the same time. Except if we look at by teacher, we can, for example, see here that Marie Curie has to teach two lessons at the same time, right? So if we go back to our solution here, right, and we add this constraint, which is, by the way, the same thing here, where we say, again, two lessons, same time slot, but same teacher this time instead of same room. Again, one hard constraint. And notice how the constraint is actually isolated from the previous one, right? So yeah, you can add and remove constraints in isolation. And each of these are incremental, and behind the scenes, it does reuse things from each other, node sharing and stuff like that. But you don't really need to know that. And if we go back to the code here and to the demo and we solve that, what we see is we don't have that problem anymore. And so we can continue again for the student group where we have the same problem. Again, we just add that constraint there. The implementation is very similar, right? And those are all the hard constraints, right? So when I
does the ordering matter? Like whether you add them or not?
No, the ordering doesn't matter. What does matter is how much you give it the weight, right? So in this case, Optaplanner can still fulfill all of them for all kind of combinations. So for any two lessons at the same, it will check if this constraint is fulfilled, right? If they're at the same time, the same teacher, the same time, the same student group, and stuff like that.
Okay.
But if it's here, we don't have to make choices yet, and you can really see that over here. We have 0 hard constraints broken. You can see that if you just look at by room or by teacher or by student group, you will see that there are no conflicts. Where it gets more interesting is when you need to make choices, right? And that's where you get into policy making in your planning, right? You can get different stakeholders wanting to have different things. So the nice thing with Optaplanner is we can actually take that as an input, which is so you can write a UI where say I want to focus more on cost minimization, or I want to focus more on an ecological footprint reduction, stuff like that, right? Or employee happiness and things like that. So here are a couple of other these constraints. So this is a soft one. It's called teacher room stability. You got to get used to reading this kind of API a bit. It helps if you think about it like SQL in many cases, right? So like this one here, we do a select from lesson, join with another lesson where the teacher equals, where the day of the week equals. So now we have 2 lessons for the same teacher on the same day. And then we're going to filter out the ones where the time between the 2 lessons is less than 30 minutes. Why is that? Teachers really hate when you have 2 lessons, one at 9 o'clock and one at 3 o'clock in the afternoon, because it loses all this time in between, right? If that makes sense. Yeah. So, and this is the time efficiency constraint. So you can see that in the solution we have right now, there's a number of gaps in here. Right? And so if we actually enable this constraint, if we go back and we enable this constraint, you'll see that this is a soft constraint, but that Optaplanner pushes them together. See?
So I've got a question for the audience. Is like, I know that you're seeing a bit what Optaplanner can do. Can you think of a set of use cases where you would use it, inside your app or other apps, or like, hey, I could, instead of big set of ifs, I could use that and have that automated. So, give us some examples.
I always think of like AI is like a lot of if statements. Planner is more a lot of for loops, iterated through different things. But yeah, no, it'd be fun to see different use cases. So we actually got a question from Jennifer who's saying how to dynamically set up the constraints. Yeah, go ahead.
You stop and restart Quarkus really fast.
That works. That's what I've been doing now. Dynamic constraints are difficult. So what we usually do is first of all do the normal, the poor man's approach, or at least the one that, it's the wrong word actually. The one that actually works very well in most cases is abstracting it, right? So instead of saying, let's say we want to add a constraint here that says the teacher Darwin hates to teach on Monday morning, right? And in fact, hates to teach on Tuesday, right? So we want to avoid giving him lessons on Tuesday. We could say we're going to add a specific constraint that says if the teacher is Darwin, then don't, and the assignment is Tuesday, then penalize it and tell Optaplanner don't do that. We hit it on the head when he does that, right? Or we could do it differently. We could say if there is let's say a teacher unavailability object, and that says that teacher A is unavailable on day X, and that teacher is assigned on that day, then we penalize, right? So you abstract it more, right? So then you can add for any teacher for any day that they're unavailable, right? That works to a certain degree. What would really be nice is if that, like in Excel, you write in a formula, that you could write in a formula in the UI and a constraint in the UI. You could design a constraint in the UI, and then Optaplanner uses this one, right? So this is one of the holy grails in constraint solving AI. The big challenge for it is that when you want to define a constraint, you really need to think formally, kind of like a programmer, right? It's still a form of code. You still, there's some challenges there. We're looking into something more like, it's like saying, can you write an SQL query in the UI? Can you design a tool that writes an SQL query in the UI? It's a similar challenge. I'm not saying it's impossible. It's just hard, not that easy.
Yeah. But I think maybe there's also different kind of dynamics, right? So one thing is to realize that the model you're editing right now, like the list of is array, you can that could be calculated like you could dynamically add stuff to that if you wanted to. I also think maybe she's referring to stuff like, well, if you have ever expanded set of rules, but isn't that where something like using rules or other ways of expressing them becomes useful?
Yeah, so in rules, one of the big things there is decision tables, right? And so with the decision tables, normal users or let's call it citizen developers or even just business analysts, they can all add in constraints. They can all then add in rules, right? In a decision table. So basically you could say if we have an insurance rate calculation and the person is under a certain age and the person has a certain history of car crashes, then the insurance rate is 15% or whatever the case may be, and that's pretty dynamic. But for constraints like the ones we have in planning problems, like in Optaplanner, it rarely or almost never fits. I had one case where we have one example where we do it. It's a dinner party example where it does make sense for some of the constraints to put them in the decision table. And that's really a case where users can just add their own constraints in that way. However, most cases is more complex. You can see that here, right? You want to select 2 lessons, or you want to do the filter. It's really like writing in an SQL query. You need to have some feeling on how, you need to have some experience on how to write an SQL query before, and the UI can only help you so far. Put somebody who has no programming experience and no SQL experience in front of an SQL tool with no guidance.
But by the way, Geoffrey, one of the things that you talked about in the podcast I listened to over the weekend was that there was a UI coming, Optaplanner Workbench. Did that happen?
Yes, and the workbench wasn't for Optaplanner. It was a difficult story. Like I've explained earlier, formalizing constraints, writing down constraints in a way that it's formal enough for the constraint solvers to understand is difficult. And I would still argue that Optaplanner is way ahead of many of the other constraint solvers here because they accept mathematical equations, right? So instead of writing things like I have like this one, right, which we just had, the time efficiency one, where we say, okay, so when I have two lessons for the same teacher on the same day and the amount of time between them is too little, they actually write a mathematical equation. So they write like there is a variable which is an int, and that it's much more difficult. It's much more mathematical, to put it like this.
Yeah, because that's actually one thing. Because another thing that happened last week was that you went on Hacker News, or Optaplanner was on Hacker News. And I noticed a lot of that conversation was actually about, well, there's this other thing. And that was why I was like, I need to try Optaplanner to understand what it actually does.
Yeah.
And what I was pleasantly surprised was that, well, I knew this, but now I really know it, is Optaplanner is much more, I'll say, practical, and less theoretical, which a lot of these other solutions seem to do.
Yeah.
I think even Google, like Google have a service that's similar, and their approach is, I also feel a little bit, mathematical.
Like you're stupid.
No. The problem, like when you look at this code, it might be hard to see it at the first go, but you look at this code, you could kind of figure out what it does, and you can tinker, you can try things, and it works more like at least that's how I feel like. If I can get it closer to how I would plan this as a human, rather than let's find a perfect expression on how to exclude these values from this domain to get it right. It's just that's what I feel that I had a hard time 5 years ago when we did the first time. Explain what's the difference between Optaplanner and other solutions.
Mm-hmm.
And at least the big one is there's someone they take the theoretical approach versus the practical approach. That's
But back to Jennifer's question, I think in practice, I imagine that in practice, when she says I want dynamic constraints from a UI, it's probably within a set of constraint types that are well defined and exposed to the UI, and there is some variables, but that would be variables within that constraint versus literally inventing your own set of constraints.
That's a good point, because one thing we do have, and we have that in the facility location one, is we have a configuration thing. So you can say I'm going to add a number of constraints, and let the users decide which of these constraints are active and how important are they. So for example, in the facility location problem I showed earlier, we can actually say that hard constraints of capacity, it's really not that important. So we can actually make it soft, see? And so you can actually change this object in the UI, send it back to the backend, and the backend can then, it will then solve versus these new constraint weights. We call this how important are the constraints and which ones are active, right?
Or maybe like the Darwin example. So some teachers will never want to do like Thursdays or Mondays. So you pre-wire them, but then in the UI you say, all right, so Darwin is an annoying person, but I'll make sure I enable the fact that Mondays are free for him. And that you can do in the UI because you anticipated that type of constraint.
Yeah, and absolutely. And so if you look at our employee rostering cases and so forth, we have those constraints in there, and then the UI in the Optaplanner employee rostering case to actually do that in the UI. We need to bring some of these into these Quarkus examples to really show the value of those too.
So shifting questions. So you say it's integrated in Quarkus, and we see it, live reloading. Like, how much work was it to take Optaplanner from what it was before into something Quarkus friendly? And how friendly is it to Quarkus?
So there's two answers to that. The point of the users right now, to give you an idea, I've been working on a new quick start since Friday, and I only worked. So Friday I worked on it a bit.
So you're not supposed to have worked on Friday.
Yeah, I know.
Geoffrey,
but it's a game, so it's not really work either. It's a Factorio game. I'll show you in a minute. It's for a game optimizing, so I'm not sure if it counts as work, but I'll show it in a minute. And I worked on, I guess, a day and a half, maybe 2 days in total. So point being, and it works. And this is because of Quarkus, right? So with the UI and with solving it, let me just show it. No, why not? Let's switch to that one. So this is it's called the Factorio layout thing. Are you guys familiar with the game by any chance? I'm not sure if this is professional or not.
I hadn't seen the game before you mentioned it to me, so I'm not much of a gamer. So,
so let me show you. This is so again, this is why it's not working. But anyway, it's a game where you have to build, let's say, electronic boards, right? Or you need to build stuff. And when you build, and you need to organize your factory in a way that when the raw ore comes in, raw copper and raw iron comes in, and you need to basically build iron and copper plates, and then the iron copper plates turn into cables, and the cables and the iron plates get together and they build these electronic circuits. Apparently you don't need plastic for that, and I'm not sure how the isolation works, but
that's a feature.
Yeah. And so my question was, how can we optimize these kinds of settings of these things that it's as optimal as possible, right? Which is basically the whole point of the game. So it's basically, how do I spoil this game, right? And the interesting thing is, think about this for a minute, that these are actually like Kafka streams for a second. Because why? What you notice here is that the production of these green things is not that good, because it's all backed up here. There's enough iron, there's not just enough copper, right? There's not enough copper wires. So if you actually add a second one in there, the second production of copper wires, you can see now the stream is actually at full capacity. And this is something you might actually see in Kafka streams too, where you need certain producers and stuff like that to actually need more of those, right? And you might think in there, it doesn't really matter where they're located because they're virtually on the cloud. But there's ping between locations, right? If you have if these three are working in North America and these are working in Europe, you will have a high ping between these locations, right? So there too, you might want to do some optimization. So what I've actually
By the way, sorry, just I want to add something. So yeah. Max and I are on the same wavelength on that one. So this is about facility. Here you're talking about Kafka streams. It actually is true for humans. So we encourage people to read the Phoenix Project and the Unicorn Project. These are books around how you organize the team and how dysfunctional we usually organize stuff is. And people have no idea, like you pour more people in and nothing happens. Even if anything, it's worse. That book will enlighten you and depress you at the same time, because regardless which company you're in, you will just realize, oh man, it's too close to truth, right?
What's the name of the book?
I would Phoenix Product.
Yeah, I'll type it in the chat.
But I wouldn't apply Optaplanner to the problems. I think that would just make it even worse. But that's
sometimes you need to be able to formalize all constraints, right? If you miss one hard constraint and it's humans related, that's not always a good idea. So let me show you what I've built anyway, right? So this is what, so the original question was, how long does it take to build something? And of course it can depend on person to person, but this one I've built in 2 days. So it's not perfect yet at all, but, and your other question is, how long does it take to, and let me just show it first. So when we press the solve button, you can see it's figuring out how do I place these things on the map. You can see it's not really optimized in time yet, but anyway, this is the optimal solution. So we put the iron into the, make plates out of this, make copper out of this. And you can imagine in a real factory, you have problems like this, right? You're not going to build from just these two components, these kinds of circuit boards, but you can imagine in a real factory, that you also need to figure out, or in the supply chain, where do I put stuff and so forth. And this is where Optaplanner can really be quite handy too, right? And this is why we have built this example. To answer your other question, how much work was it?
Because we're lost. What was the question?
The question was, how much work was it to actually get Optaplanner running in Quarkus itself, right? So the Quarkus extension and so forth. That was a bit more work. I can vouch for that. Yeah, we've been working on it for quite a while. It's working well for quite a while already, but we're still improving it. So I think, yeah.
Was it a big mind shift? Like, okay, we need to prepare a lot of stuff. Therefore, the bootstrap of the framework itself has to be rethought, like to really get the best out of it, things like that.
Yes, some bits. So, for example, in the API, we deprecated a few methods so we could have benefits in Quarkus, right? And we replaced them by some other mechanisms. To give you an idea, we built first. We have a solver config, which is our configuration of the solver. It's mostly optional these days, but it's completely optional, by the way, if you use this Quarkus extension. But we still need to. It does that based upon class path scanning in the Quarkus extension. We give that and we create a solver factory with that. Pretty much like I think in Hibernate, you have the Hibernate configuration, you build an entity manager factory. It's pretty much the same thing, I guess. Mm-hmm. But our solver factory used to have the ability to go back into the config and change stuff, which is something you really don't want because you just want to say build a new solver factory from a new solver config, because we've removed that ability, or we've deprecated that ability, and that gives us the ability to cache the solver factory. And when we cache the solver factory, that means we can build the solver factory in the future in Quarkus during the build time instead of during the runtime, if that makes sense.
So we're not doing that yet, but that's on its way, you say. Okay.
We're not doing that yet, but I think I guess the Hibernate stuff in Quarkus is already doing that.
Well, the whole configuration, mutable configuration in Hibernate was actually a problem we foresaw like way past, way before Quarkus, right? So this is something we've been working on for quite a while, like Steve Epperson and team. There's something we had fixed, and then when Quarkus came, this layered phases, very clean phases, was really a big help to benefit from the build time effort.
Yeah, absolutely. And so I'm looking forward to when we actually can. We already don't parse the XML anymore at runtime, if there is an XML, which is a great thing. If you now don't have to create a solver factory anymore at runtime, and we can replace some of the generic stuff with generated like you guys do in Hibernate, I'm expecting a big performance gain in Optaplanner. So we already have some, but it's going to be even more, right? So we still have some work to cut out for us, actually.
Is that so right now Optaplanner is what you're saying? Optaplanner right now is just integrated, like on a normal level. There's no not that much built up time optimization and not much like reload or.
Well, there's a bunch already built up. Let me give you an example. So if you go to the school timetabling one, let me go to the. So this is the school timetabling one. We jump into application properties there. We have a bunch of properties we can already play with, right? So we can say how long it's going to solve. We have a whole bunch of terminations already supported. We can say if you want to use multi-threaded solving, donate multiple cores to Optaplanner. That's basically that option. That's actually this one. How many we want to solve in parallel.
By the way, if you want real time, so like bandwidth optimization, stuff like that, or let's use the game analogy. So I want real RTS, games. Yeah. So I want a StarCraft optimization, which in some way StarCraft is really about resources, right? So the game you gave was an interesting example, though it's I imagine it's a turn-based game somehow, but StarCraft is real time. So you wouldn't put 30 seconds here, you would put, I don't know, can you say 2 milliseconds or something? Like how would you optimize like that?
Yeah, it's a good question. I wouldn't use this approach. What I mean is I wouldn't, so yes, you can put 2 seconds here, but it's a cold start. You would start from probably an unassigned solution, right? What I would do instead is I would do a real-time playing start. So I cannot show that with Quarkus yet. If you're cool with that, I can show it with...
go for it.
Go for it. Okay, so with the this one, here we go. Let's see.
JFrame, holy, wow.
Yeah, I need to. I'm just hoping I'm starting it correctly because. Yeah, let me hold on for a second.
Who knew StarCraft was written in Swing? You know?
I didn't prepare doing this, so you can see IntelliJ is still. I did do a checkout at some point, so let's just hope this works. But let me just tell you what. Yeah, it's always nicer if you can show it. But what we do is I can show you on the solver. Right, so on the solver interface, we have the ability to call something called an add problem fact change. And so just to give you an idea on how that works, let's find some usages of that. Here it is. Let me just first show you, and then I can show you how the implementation works. So this is a vehicle routing problem without maps integration. We have some with maps integration too. But anyway, let me take a data set here. Let me take, anyway, it doesn't matter. No, let me take one of the Belgian ones. So this is a Belgian one with actual road time, right? And so we'll take this one. Okay, and now we need to, and we no, that's not going to work. I'll take this one because, yeah, there's no maps integrated. Okay, anyway, let me show this one. Sorry. It will run, but it won't allow me to do real-time planning, which I want to do here. So here's real-time planning. We have this solution, right? It took a while to actually get to this to minimize this distance. So basically to minimize the amount of time these vehicles are driving around. And before I show you, we did this for tens of thousands of vehicles for a Fortune 500 customer, and they expected to reduce their driving time by 1 to 2%. We actually reduced it by 25%. That was.
Were they doing it manually by hand, like with a fixed algorithm before, or just handcrafted?
No, they had some sort of other algorithm. They tried this against the Google one, by the way, and another one too. So, and we did in 5 minutes what they solved in 3 hours. So, do note that in the beginning it's the highest. It's the law of diminishing returns, right? You get 25% in 5 minutes, and you get another 1% the next hour, right?
Yeah, of course.
But the impact of this is hundreds of millions of dollars. This is tens of millions of CO2 emissions reductions and so forth. It's insane. And we see this we see this in many vehicle routing cases. Vehicle routing by far is the most profitable of all of these AI cases, or most influential ecologically and so forth. Anyway, and so when we assign the location here in real time, you can see that Optaplanner picks it up quite quickly, right? So you can you can see I can start clicking around. It becomes more difficult because in this particular case, you can see that the vehicles are filling up. So it's not just the distance that counts anymore, but actually getting all of the items into the crammed into the vehicle, right? But this is a form of real-time planning. Does that make sense?
Yeah. Well, it's FIFO, right? If your packet was too early and then it's dropped because the new packet coming.
Yeah. And you can see that the distance also doesn't go too higher. So if you start from scratch, we start much higher than we start at 900, right? It takes a while to get down to 70. And now when we add one, it's immediately in 70, right? And so yeah, that's real-time planning, and it's one of the reasons. So that's a nice thing. When you then do night, so what we typically do is we do nighttime planning, where we take let's say half an hour or an hour to solve all of the the use case, the data sets that come in for the night. But then during the day, we do this kind of real-time planning to really react in milliseconds on changes in the field, right?
And the fact so what do you store when you say I already have a current working solution? So it's just starting from that is enough, or you have also caching context of what you've computed in the past that is kept around?
Yeah. So from the user's point of view, you have to adjust that solution. So just to give you an idea on how that works in the vehicle routing case, I can jump to the code here. Let me say find usages here, and let's say the vehicle routing case, right? Examples. Oh yeah, it's a bit more complex. Yeah, I've abstracted the way. I can show you in the vehicle. Let's jump here. So there's a bunch here which is optional, but I think over the solver here, No, I didn't actually. Okay, I can show for cloud balancing. Yeah, it's going to be confusing. I think it's in the UI here. I need to find it where it is, but it's somewhere here that I. Let's see. Here it is. Here it is. I found it. So what I'm doing is, I'm doing saying, okay, I have a certain solution, a vehicle routing solution, and what I'm saying is, our problem fact change API is still a bit difficult, but what I'm basically saying is, I'm going to add a new location. That's the big thing we do here, and we do some notifications to Optaplanner about that, so it can, if it wants to work incrementally around this, right? You can see we add a customer to the new customer, we add a new location to the list. And so forth, right? And so we basically call that solver method, right? So we call that, and this is when you do real-time incremental changes. It's through a callback, right? Yeah. This we call it, it has one method to do change. Yeah, it's not it's one of the things we want to simplify further, real-time changes. Right now, the APIs for non-real-time changes are very clean and very simple. Like in the timetabling example, this is also one of the reasons why it's not yet in the school timetabling one.
Okay, I have to drop, unfortunately, and I know we started a bit late, and I know Max had plenty of questions, so I'll let you continue on the episode for a tiny bit, and I'll definitely catch up afterwards. It was great, Geoffrey. So thanks for explaining that. It's always eye-opening. It's like, oh, I could solve so many problems.
Thank you, Manuel. Thank you for the questions.
Goodbye.
Yeah, that's again, like for me, the real fun part is like, yeah, you showed these, I'll say, not complex, but like complete problems. Like they're very nice and shiny, which they are, and they're very good. But like also just stupid simple things. Like I have talked to you last week was, I got this new monitor. It was very big. Layout the windows. It's actually an annoying thing. And I realized, hey, I can actually do this layout thing. I wrote literally a program, and it took me less than an hour after. Well, you told me, guided me a bit, but once I had it, I was like, oh, this is super, super simple, pretty basic. Actually, I'll show you I'll give you the link for those who want to try. This is like this. It's like one file. It's a JMang script. Yeah. If you want to try it out. But it was basically very like I laid out. Hey, I have these different areas, like a grid on my screen, and I have 50 windows with different names, and it was like, hey, tell me how to lay this out. And it's not perfect yet, but I can definitely see how it was just so easy to express. Oh, okay, I want my main app in this place, and I want to say every window shouldn't overlap. Every window should be as big as possible, and it gave me an answer in a few seconds, and I know it can be optimized. So so
it is a challenge though, because it is a challenge. It's a bit of I was a bit skeptical if we were already good at these kind of things like 2D surface planning, but I think we found a good solution that will give good results, right?
Yeah, I think there are. So, Jeff. Oh, good, Jeff.
Yeah, but what I see is people usually have trouble modeling. That's the difficult part. What is the planning variable? What changes during planning? And and sometimes it's very easy when there's an example like the employee rostering or the vehicle routing, and then you add in more constraints. It doesn't really matter. But sometimes, like in your case, the layouting thing really had me scratching my head for a second because the original
well, that's the thing I got from was like you have a big screen that has millions of pixels, and if you tell Optaplanner, hey, try and lay out all these images in all the pixels.
Yeah.
The solution space is like gigantic.
Yeah.
But if you scope it down to be, there's certain squares on the screen, so there's a factor of 100 less solutions. then it becomes, and instead of being trying to move every pixel, you just say move a square, and they are very fixed. So I think that's the challenge of figuring out what they are. Reduce the number of parameters.
Yeah,
so it
absolutely.
becomes. Jeff, before, because I actually have a question from the 5-year podcast bit. But do you have anything else you want to show, or did you get through all your?
I went through all the Quarkus demos, except of course the Kotlin version of the school timetabling, which is the same thing.
Sure.
I can go a bit more into code of these, but and we have many more examples, and you'll see many more of those. And you'll see more showing up from Quarkus because basically, every use case we're trying to have many use cases, and so for each use case we want to have a Quarkus version or over time, hopefully, right?
It's by the way, my example, I don't have it moved to Quarkus yet, but I will do it because I realized with Quarkus I can remove a lot of the wiring stuff I have, and it becomes a super small example. So I saw that we had someone just from Tokyo Walker. Not sure if you know him. He says, off topic, Debian code is very complex. I'm not sure what that came from.
Yeah, the problem with these, if it's if there's an opponent, then it's you typically need a different algorithm than what you need with Optaplanner. In Optaplanner, you have a centralized planning case. If there's an opponent who actually undermines what you do, you could use it too for some of the cases, but not for all of the entire thing. Let's put it like this.
Okay. So anyway, I do actually have a few, because if those who are going to listen to that podcast, there's a question we actually asked back then. So you talked about the workbench. You said that kind of didn't happen, or it's a different thing. And you did have multi-threads, but it sounds like you have that now.
Yes. Yeah, we have multi-threaded solving. So I can show you. So I haven't tried it.
Does that make a big difference?
Let's turn it down. So what I'll do is I've turned on multi-threaded solving by doing this. Let's give it 2 of my cores. If I ever give it all of my cores, then I will be thrown out of this session, right? So let's not do that. Let me give it 2 of my cores. Let me also change the problem a bit. So this is for school timetabling.
So the way you do thread is that just like an on-off thing? Like the way to change the problem?
Yeah, I call it how many cores do you want to give to Optaplanner. So I'm going to donate, let's say, 2 cores to Optaplanner. I can probably show that if you want in the course wise. And I'm going to change a little bit the problem because I'm going to make it a lot more difficult. So in the Factorio thing. So let me just throw out this one and throw in 2 of these. And for those who know the game, it's a much bigger problem now. We need to build this stuff. This is the green stuff and the red stuff, and you can see. Oh, okay, I didn't try this out before, so this becomes interesting. Let me take a look. What went wrong? Yes, of course. We need something called a planning ID, and yes, of course.
Okay, probably something for the.
Yeah, for this, we need a planning ID here. So let me just quickly add that. I think public string get ID or something like this, right? Return x plus y. This will probably do it. Let me just see if that's enough.
So that's for is that for sharding the different?
Yeah, for multi-threaded solving, it needs to be able to take an object that's in one thread and give it to another thread, and then make sure that somehow figure out that the object that was already there, because it's an incremental state, was the same one. And so that's why you need basically an ID on your objects when you do multi-threaded solving, which you don't need if you don't use multi-threaded solving. Let me just see if that actually fixes it. That looks better. So let's take a look. Scroll down, it's restarted, it's solving, construction heuristic ended. So we should see the first solutions popping up here.
There we go.
And so this is now using 2 cores. And if you want me to prove that, let's take a look. Plus resources, should be using 2 cores. I'll see in a minute. A bit hard to see, but yeah, I can stop this and give it 4 cores, and you will see. Oh, let me just do that. Stop
No,
this.
that's fine.
No, yeah, but it's a test. Always interesting to try this stuff live in a demo, right?
Sure.
Oh, and this one is still solving too, I guess. No, it's not. So anyway, so you can see now is it solving? Solving. Here we go. And so this was the first time with 2 cores, and this is now with 4 cores. So you can clearly see it's using more CPU. It's making my room heat faster warm.
You have a bigger while waiting loop. Yeah. Okay. But that's nice. But that means that you can finish faster, right? Is that generally true? Like even for small problems, it's better, or where's the threshold?
Yeah, it's an interesting thing. An interesting question. We've seen in some cases that you can get the same solution in half the time, right? That doesn't mean you can the twice as good solution in the same amount of time. It just means that how can I show this? Let me give you vehicle routing. This is a typical vehicle routing time versus score graph, right? And so what it basically means is you can take this particular line here, the purple line, and make that all, instead of 5 minutes, make this 2.5 minutes, make this 1 minute, and so forth, right? The 2 minutes make that 1 minute. So you can basically get your to flatlining scope faster. It doesn't mean you can, if you can do this in half of the time, you get what you get at 2.5 minutes. It's not really a big difference, as you can see, right? It's a big difference if you only have 2 minutes time budget-wise. You can now do that in 1 minute, right?
Yeah.
So, and depending on how many cores you can give it, we do notice that depending on how fast your score calculation speed is and a number of other things, and you see the solving stopped. Let me choose this back here. It's stopped. That there is thresholds into throwing more cores on it right now doesn't always increase the speed. We have a couple of ideas to improve it even further. As far as I know, we're the only solver on the planet who does incremental multi-threaded solving for algorithms like local search and so forth, right? It was a very difficult task to get this rolling, not because of the multi-threaded solving part, because of the incremental part. We need to make sure that the calculations are still incremental. So when you change one lesson to another location, or in this case, you change one of these assemblies to a different square, that it only calculates the delta on the score effect. And so when you have multiple threads doing that, you need to make sure when they talk to each other. So when when one thread needs to execute a certain move, that it can actually do that based upon the state it already has, which needs to be completely isolated, of course, from the other threads, right? So that was a big challenge for multi-thread solving, if that makes sense.
Okay, well, that was fun. So 24 hours later,
Yes.
Whoever who is viewing right now, let me just check that I actually am live, so we don't actually.
We have one viewer, 2 viewers.
Right, so I work now. Great. So anyway, those who are tuning in, yesterday we were recording this episode. I just came back from vacation, so I had I was what's it called?
Murphy's Law.
Murphy's Law kind of thing. And in the hour that we were talking, my internet provider decided to restart my internet because I opened a case a week ago, and they thought, oh, we couldn't reach you because I declined the call. And then they said, oh, we'll just restart quickly, which they did. And I had lost my internet for 5 minutes, but then everything was bad. Anyway, so you'll notice that I have a different shirt on. Jeff, you don't have one, but that's, one of us at least shower. So anyway, no, I know what we mean. Anyway, no. So we just kind of wanted to conclude what we talked about yesterday, so that we can actually upload a complete video where things make sense again. So that's the idea. So yeah. So anyway, sorry for you guys and those who are here 10 in the morning. Say hi. Oh, actually 18 people. So that's good.
Yeah.
Okay. So anyway, guys, if you have questions, then shoot them. That'll be good. Then it won't be all for nothing. But I actually had, as yesterday, we recorded an episode 5 years ago. I listened over the weekend, and there's just some questions I wrote down from back that I wanted to kind of conclude and use that as the ending here. And there we go. Okay, so one thing was you were participating in this competition. I forgot the name of it now. I guess is that a yearly thing? Anyway, 5 years ago you were participating in it, and you got to a second place, very close. And you said that the ones who won was they used a dedicated kind of solution, and therefore they could solve the problem better than you. But you were still proud because you had a generic solution that could actually be extended, which was one of my things about Optaplanner. So I was just wondering, 5 years later, have you won yet?
Well, there's more competitions going on. We haven't been first yet. The researchers always keep raising the bar too. But as for production solvers that are runnable in a production environment where you have things like logging and reliability and stuff like that, we are usually one of the first, right? Not always. It kind of depends on the case. And we've had less time these days to really go into many of these competitions. So you have the yearly Santa competitions, which are pretty good. You have the Google Road Dev, not the Google one, the Road Dev competitions, which are really good. It's every 2 years. They have one now around maintenance scheduling. We should really participate in that. It's just it takes time, and there's not always time anymore. And apparently, when we do have time, I'm building a Factorio example instead of maybe building the maintenance. We are working on a maintenance scheduling case, but it was actually different than the one they have in that competition. So we won't.
What's the maintenance schedule? Is it like who's cleaning or?
Yeah. So let's say you have a train network, or you have an electricity network, and you need to do maintenance on that network, right? So you need to decide when, or internet, for example. When do I disconnect this internet hard line going through the country, right? And so when you have circles in these networks, you can actually unplug part of the network, right? And then, like trains, you can actually say, I'm going to do maintenance on this train track and send the trains the other way around, right? Or especially with electricity, you have this case. And then with maintenance scheduling, you have to decide which line will you do at which time. And of course, after a period, let's say a year, every line needs to have its maintenance. But what happens during the winter, you don't want to spend, doing maintenance on the power line that goes through the Alps or something like that, right? You want to do that during the summer because the risk of breakage is much higher, right?
Okay. Yeah. So what else? So anyway, so you didn't win the competition yet? Is that what you're saying?
No, yeah, that's what I'm saying. We didn't win yet.
Oh, is it the same case where the scientists who have the time and not have to do a product?
Yeah, they spent 3 months on this. We give you an idea. Last time on the last Santa competition, we built something. Some of my team worked a bit longer on it, but the first thing I built was I built on a day, and we had a pretty good solution. We were up I guess we were like 70. I don't remember. We had a pretty good solution. If we really wanted to get to the optimal one, we'd have to start writing custom moves and so forth, which take us probably a couple of weeks, maybe a week, maybe 2 weeks. And in the end, I simply didn't have the time anymore. Kids now and so forth. So more, work-life balance, stuff like that.
Okay. So
there's one interesting thing about this. This is an opportunity that Quarkus gives us. So there's a traditional argument that says that custom solvers will always be better than generic solvers like Optaplanner. And the argument goes like this: it's because generic solvers need to do reflection, right? They need to somehow go into, this is a shift object, get the employee from there and so forth, right? And that is always some performance overhead, right? That's a generic argument. With Quarkus, that's a game changer, right? We simply generate the actual code to get, do shift code dot get employee at build time. So at runtime, there is no reflection anymore. So that's going to be a game changer for us, I think, or at least going to change that the performance and well.
So I just, because we talked about that just 40 minutes ago. Is that one of the things you have now in the integration with Quarkus that you
Not
do?
yet.
Not yet, but that's coming. So
that's coming. And for the users, they won't know. It's just they will upgrade to a version, and all of a sudden they'll see it go faster. So the speed will depend on the case, though. Some use cases do much higher, have a higher score calculation speed, so they will benefit from this more. Others have a lower one, and so we lose performance on much other things than this, right?
Okay. So what I'm hearing is, in 5 years, you're still in the same position. You're almost winning, but now you actually have a product. You have kids. You have a life. So overall, I would say that's good.
Yeah, we can power tweak, and we have more generic power tweak moves. But it's still, if you want, sometimes for these things, if you want to be, it's easy to get to the 5 top percent. It's hard to get from the 5 to the 4 to the 3 to the 2 to the 1%. It really takes time, dedication, and knowing the problem domain very, very specifically. And so this is something that Optaplanner strongly believes in. We believe, like in the garbage, how you deal with a garbage collector in Java. Out of the box, it works well for 80-90% of the cases. And then that if you want to go that extra mile, if you want to get that extra bit of performance out of there, even in those 80 or 90% cases, right? Then you power tweak, and then you go into the solver config, right? Either through the Java API or through the XML if you don't like, if you don't like either of those. But then you power tweak, and then you spend a lot of time for an extra 1%. And if that one extra, and then it depends on is it 1% of a small use case or 1% of a large use case where it's $1 million, right?
So what you're saying is that these are they are specialized situations that are if you can spend time on it, but the time stops when the competition ends, right? But in real life, you can start with Optaplanner, you can get very close, very fast, and as you said, you maybe gain 20% savings just by applying Optaplanner. And then, of course, you can then over the next couple of months or years, you can be rolling out changes, and then you can add those 1-2%, and depending on you can save extra money that way. But that's the right?
And one thing we're doing is for specific use cases like the vehicle routing problem, which has many different variants and which is everywhere. It's anyway, for those cases we add specific moves, for example, custom moves. This is something you can add in Optaplanner to make it go faster or better, deal with certain situations better. And so we were working, for example, right now we're working on a K-opt move, which is a type of move. It's hard to explain. It's something in the algorithms. It's a feature inside the algorithms. It's just something we mix into the algorithms. One thing we've also noticed is that, especially, for example, for vehicle routing problem, is that we have certain features that when scaling out, are a huge difference. For example, nearby selection. That is the kingmaker for us for vehicle routing. And when scaling out, that is the reason why we do in minutes what others do in hours, right? Or the competition does in hours. Now, the problem is, it's not on by default. Why not? Because it's great at scaling out, but not that great at scaling down. And so we haven't really investigated yet into automatically figuring out, okay, this is a big problem or small problem, and automatically turning it on and off and stuff like that, which we should. It's just, auto-tuning the garbage collector based on, the runtime information. That's kind of features. That's the kind of features we will be working on towards the future. So we're going slow in the sense that we. Yeah, instead of focusing specifically how do we win this competition, we're really playing the long game. We're saying, okay, how can we add features that we automatically win this competition instead of spending a lot of time in it, right? And that will take us longer, but we are making progress, right?
Okay.
We've spent a lot of time right now on ease of use, and and we want to spend some more time on the algorithms. We have some improvement, we have something now on the way. More welcome, definitely.
Is that because that was one of the things when I was playing with it over the weekend? You told me I got this layout problem of the windows, and it was pretty good. And I was like, I wasn't sure what if it could do better or worse if I gave you more time. And you pointed me to you have this best benchmark tool. I think you showed a screenshot of it. But for those who don't know, it's like it's literally 3 lines of code, maybe 4, and you basically say, hey, given this Optaplanner, what's it called, the solver config. And here is the starting point of the solution. Give it like, so I gave it like 3 solutions. One that was like 2 windows, one with 10 windows, and one with a 50 or 60 windows, something. And I gave it to the benchmark, and then you basically just run it through all 3, and out came a graph. I could see, oh, it actually reaches the like it can't get further in very short time with the small ones, but with the 50. It actually maybe could do a bit more. Is it possible in there to tell it, that benchmark to say, hey, go and tweak these, like activate the, what did you call it, the K Optaplanner, is that?
We have some blueprints in there. So what is a blueprint? Is just you tell the benchmark to try this blueprint, which basically means it tries a set of different algorithms and will tell you which is the best one. It won't tweak on K-ops and stuff like that. It won't go into the algorithms and what we call the neighborhood selection or the move selectors, not yet. But it will tweak between the different algorithms. It's not that smart that it will auto-tweak some of the parameters yet. We could do that in the future. But you can do it very easily yourself, because we have 2 ways, but one way is you can just say, I take my benchmark config and just say, okay, I want to try the value 10, the value 20, the value 40, the value 80, the value 160. Give it some time, let it run during the night, and in the morning you'll know what you want to use in production, right? And this is where this benchmark report is for. We actually use it inside these competitions all the time.
I was very amazed. I was like, oh, this is very complete. It's like I haven't seen the report before, but I like, oh, this makes sense. And then,
and you can turn on additional statistics, like giving you insight into the rules, like which of the rules violate most of the constraints and stuff like that, which of the constraints are most penalized and so forth. It's a secret weapon. We often come into a situation where we go with customers and so forth, and and sometimes they say, okay, we want to get more performance out of this, right? For whatever reasons. The first secret to know for when we're using Optaplanner, the one metric you need to know is the score calculation speed. It's the last line of the info logging. It's also shown in the performance graph in the benchmark report. And if that number is extremely low, that's for us a reason to say, okay, let's first focus on that, right?
What is low?
So
5? Is it 1 million? What's the?
So anything between 5,000 and 10,000 is okay. Above 10,000 is good. Great is actually great. I've seen 20,000 for 50,000, 100,000. That's just great. That's great. Below 5,000 is between 1,000 and 5,000 is just doable. Let's try to crank that up a bit. Below 1,000 is bad. So
and the reason why to get there is because either the constraints are there's too many or they're too slow, right?
They're too slow, or there's something going on. So it's the number of moves per second, the number of solutions it evaluates per second, basically, right? And if you give it a twice as fast score, that number will go up twice as fast. But I'm really not too worried about if it's 1,000 or 2,000. It's really about
It needs to be above 5 or 10. Okay.
Yeah, I've seen cases where it was 1 or even 0 because it rounded down, and so then it doesn't really matter which algorithm you throw at it. It's just the speed isn't there. And so this is something with the constraint streams API we have right now. It's less likely that you'll end up in a really bad situation. Not saying that the constraint you can power tweak with some of the other approaches to really get much higher numbers sometimes. but it takes an awful lot of work and an awful lot of checks and tests to make sure that it stays things. While with the Constraint Strips API, you just get good performance, good enough performance, and you can write it fast, and you've seen the rules, right? In 2-3 writes, and it's still incremental. You can do it with an easy calculator too, with 4 loops. That's going to be faster to implement, even feel much more natural even, but you're going to get 5 calculation speeds or something like that. And so this is the secret weapon for us. When we see that speed is low or not, all that information is in the benchmark, right? So that's the first thing we usually ask. Run the benchmark, we look at the report, and we start figuring, and based on this, on the way the graphs are showing, we can actually see you need to look into where the construction heuristic is too slow. Is it the local search that's too slow? This is power tweaking. You open the benchmark, you want to start power tweaking. When you say, default is not good enough. And in most cases, default is good enough. But there's cases where it's not, and there's cases where spending that extra time is more than worth it, right?
Yeah. No, and as I said, I did study some of this problem area in university 20 years ago. It's the same. So if you just know a little bit about it, but I even so if you don't know, if you see when you see the report that the tool does, you can just see, okay, it's because there's this graph that shows the value of the solution or the problem, and then you can just see it goes up and down until it finds an output. Right?
You want me to show it quickly?
Sure, if you can.
Yes.
Let me know where I can.
I'm ready. You can share my screen.
Ready? I'll share your screen. There you go.
So this is let me just this is the one you want to look at, right? So this is
yes.
This is the typical. So this is the report. You have a whole bunch of information on here. So what I did is I picked one data set here with 5. Let's pick a bigger one, right? So this is one with 1,000 locations for vehicle routing, and you can see multiple algorithms next to each other. And so this is the time at the bottom, and this is the score. So you can see, basically you want to be on the top left corner, right? Top left corner is good, fast and high quality. And you can see that, you can clearly see already here, this is actually nearby selection versus non-nearby selection. So the blue and the green line here are non-nearby selection, and the purple and or the pink and the yellow line are nearby selection. Right, and then there's 2 different algorithms there, but you can clearly see that nearby selection just wins over the other one over time. Right?
Sure.
And if you even go to a bigger data set, this is so without nearby selection, this is a bigger data set. Here nearby selection completely wipes the floor. Right? The other one.
No, and this is a lot of data. Well, not a lot. Like my data, the ones I had was just for comparing, because I need mine to be fast, within a second, right? So it's 1, 3, or 5, and it's just that was much more coarse grained, but it was just very clear to see. Okay, when more Windows comes in, these constraints are different. So, anyway, for those who are listening, if you try out Optaplanner and you start getting it going, just know that there is built into the tool. You literally just go, build performance what's called benchmark. Based on this solver, and give it a set of problems, and then you say run, and there's a command that says open in browser, and it's there. It was very easy to do. Okay.
You have a bunch of other reports here, like score and return on investment. That's always nice to show. Versus the default algorithm, what kind of profit do you make, right? Or put it like this.
Hey. No, that's very good. What else did I have in my question back here?
Let me switch back to...
Yeah, I'll switch back. I'll just turn that one off. There we go. Oh, there we got the multi-thread. We talked about this yesterday, I think. Then you mentioned, this was funny because this was 5 years ago. I can't remember which were. We actually talked about OpenShift in there. And one of the things you talked about was an Optaplanner execution service.
Ooh, so that discussion started again recently. It's still in the pipeline. That's the short answer there. There's a lot of promise there. There's actually multiple of these cases in the pipeline. But so we've had a lot of success with vehicle routing. We had a lot of success with employee rostering. and diverse kind of cases, maintenance scheduling, task assignment, that kind of stuff. But for cloud balancing, we've seen a couple of usages, but it's nowhere near the amount of usages we've seen with the other cases yet. So I still believe that's an untapped potential. And purely
which one? There's one is
cloud balancing. So assigning processes to machines, pod to containers, so container pods to hosts, assigning, let's say, hardware into stacks. So we do have a number of usages of it. We had Overt in the past. We had a number of people in the community using it like that, and the results were pretty good, but it hasn't caught on yet, and not nearly as much. Let me put it like this. Yeah. So
go ahead, Jeff.
Most of my time I'm not spending in use cases around this area. There's far more about vehicle routing, employee rostering, and maintenance scheduling and so forth. And there's many more cases, but those are the lion's share, to put it like this, right?
But do you think so? The cloud optimization problem is more the. Do you think that's because let's say vehicle and schedule is like, it's a very traditional planning problem, and it's something that is it takes a while. It's like maybe vehicle planning is like from day to day. Planning for a schedule is like every six months, but cloud optimization is like every millisecond. Right? It's like it has to happen fairly quickly. Is the reason why it hasn't dropped out is because it will take too long to get to a good result, or it's just because that area isn't used to? They just we just going to use traditional what's called not OpenShift's operating system, but there's like years of research of traditional ways of how you should schedule resources, which I think works in maybe 60% of the cases. But once you have the cloud and you start having a better understanding on, this you can actually annotate jobs saying, hey, this is actually like a high intensive CPU thing, or this is like where you can actually express more things. I assume Optaplanner could do a much better job, but
yes, it can. I'm sure of that. We've seen the results that it can, and we've heard cases, right? There was a case where they used it on a power plant thing around cloud balancing, and they clearly saw an improvement. That's not really the problem. So it's a really good question. It's not really the time release problem either, because what you do in the cloud balancing case, again, whether you're assigning pods to hosts or you're assigning Kafka streams to where you want to host those producers and consumers as to where they're being consumed and so forth. That's a new case, by the way, right? But it's all the same thing. That's not really the time thing is not really the big problem, because the moment you say, okay, I need a new pod, right? You need to give an answer immediately. And you cannot say, wait until I have 10 more requests for pods, and then I'm going to figure out between those pods how is the best to schedule it. No, for each pod that comes in, you need immediately to allocate it to a host. So you can't actually you cannot optimize the moment the pod is requested. What you can do is you can at night or all the time, you can defragment your cloud, like in Windows defragmentation, if you remember from the 90s, right? This is exactly what you do. So you basically say, okay, on hosts where we have a lot of memory being used but very few CPU being used, we take processes or pods and we move them around such that pods that take high CPU are together with pods that take high memory, and so together they use up all the system resources, right?
Okay, got it.
This is you play Tetris. It's a game of Tetris. Right? Okay. And so this is a huge opportunity. It just hasn't crystallized yet. Maybe the wrong. It's more of a practical thing, I think. First of all, you need to have the telemetry data, right? So the industry needs to be ready to have all that telemetry data. Second of all, you need to have the architecture to be able to plug in the scheduler and so forth. And then you need to just connect the right people to get this done. And that hasn't happened yet. And it does. And it's a pity.
Well, we should be talking to some of our friends in IBM Cloud and the OpenShift team and see what we can do there. that would be fun. Yeah.
Some conversations have started recently. So we're I am optimistic about this case again.
Yeah. But anyway, so that was actually my other question about the cloud conversation. But the one I had about the Optaplanner. Oh, so that's. But I think on the call, the execution service you talked about was not about planning the execution of the cloud. It was to have a service, so you can have Optaplanner as a service kind of thing.
That's a different story.
Yeah. Is that in the books or? Well, I know it's been talked about, but I was just funny that on the call 5 years ago you mentioned it. I was like, oh, okay. Yeah. If anything, but that's still. Yeah.
So the big thing for this there is Quarkus, right? So in the past, to set up a service, or in the past we needed a solver config, right? Nowadays we don't need it anymore. We just look at the class path, everything else gets defaulted, and so only if you need to. And important things like if you want to really specify the amount of time, you can do that through the application properties and so forth. The next step, actually, what I'm playing with right now is, can we generate a solver service just based on the model and the constraints? Because everything else is just boilerplate. Actually, I didn't show it yesterday, but we had a timetable resource where you say, okay, comes in a solve REST call comes in, and what we basically just do is we take the timetable and we call the solve method, right? In the past, we now have we've for example, now we've created a solver manager which manages multiple solvers and the solver threads around that. And in the past, you had to manage your own solver threads, which means that if you call the solve on a REST service coming in, you would have a HTTP timeout, because the REST call comes in, you call solve, it goes to solve for. Even if it's just 30 seconds, but you have it, if it's 5 minutes, an hour, you get an HTTP REST time, right? So we solved that part already. That's available already. That's available for a couple of months now. The next part for us is to just say, okay, here's your model, here's your constraints, and you automatically get a solver thing. Very much similar to what we do with the Cogito project for Drools and JVPM. Very much similar to what the Quarkus Panache REST API does, right? Where you say, I have my data objects, and it automatically generates CRUD REST methods, right? And this will standardize a lot, right? That's the next step, and this will come relatively soon. And then once we have this, adding services on top of that, which you can just use, exposing them in the cloud. That's the service we will be exposed. Yeah, that's sugar, but that's the service we will be exposed. We will have a few more challenges, I guess. There, we don't know how deep the water is entirely there yet, but we'll come through those. So yes, it's coming, definitely.
So the other thing that was on the call was a fun one, because you were talking about you start exploring DevOps and taking the data from DevOps and doing this OptaConf and proposing a thing. And Emmanuel actually said, "Hey, we should get you in contact with the DevOps guys."
Yeah,
I think that actually happened, right? Or
yes.
That you. So you're planning the schedule for DevOps. Is that still going on, or?
Yeah, it's actually gone further than that. So 2 years ago we had we did this both for Red Hat Summit. 5,000, 7,000, 8,000 attendees, and we did this also for DevOps now. So for Red Hat Summit, we did it twice. We were doing it again this year. We had this nice schedule, and then they said, "Yeah, let's throw that away. We're going virtual," right? Because the moment you go virtual, half of the constraints, most of the constraints don't matter anymore, because people can just it's a very different experience. And then for DevOps, we did 2 years ago. We actually did a competition. One-on-one. So 2 years we had a standoff. We had a DevOps talk about that too. You might be able to link it. And so we had another competitor also doing half of the schedule and us doing half of the schedule. We did the conference part and they did the university part in the end. It was an interesting experience. We had better results. That's why we got the conference part, I guess. But it was it was a good race. They gave us a run for our money, to put it like this, right? And then the year after, that was 2018, and then 2019 we scheduled the whole DevOps Belgium thing. So they went just with us. We had the integration. It just worked nicely. And even up to the point that it's now integrated into the Devox CFP application. So they don't run the Optaplanner examples anymore and press the REST import button anymore. No, they took copy pasted that code right into the CFP. So any Devox CFP right now,
nice.
None of course right now, but anyway, any Devox CFP where actually has the ability to generate that thing.
So in like 3 or 4 years, when we can live a normal life again, then Optaplanner will be used for that one.
And it did it in 2019. So if anybody was presenting in 2000 at Devox 2019 and their presentation was too late or too early, it's Optaplanner's fault. I'm sorry. Optaplanner's fault.
Very nice. Okay, what else do we have? Yeah, so this is the one I actually left at the end here. So this is the last questions of the day, unless someone else has a quick. I saw Raz was saying CRUD method name resolvers. That's a reference
maybe I mispronounced it. So basically, in Quarkus you have the panache stuff, right? With the and you have the automatic generation of CRUD REST services if you turn it on. It's very useful. We use it now in one of the examples. We didn't find a bug in it, but it's solved for Quarkus 1.9, which is out. So right now it's perfect.
Okay. So anyway, the one I had. So this is actually because Optaplanner 5 years ago, big data AI wasn't something everyone talked about, and I don't think. Did we have? I think that was when they started having they were beating the Go players and that kind of thing. They were using these there was some breakthroughs 5-6 years ago. But in the last 5 years, there's this AI and TensorFlow and all that stuff. And I know that AI is probably the word AI has been stolen, and that's what AI is. But I believe Optaplanner is a part of the general AI problem. But maybe could we just spend the last the exit here and say, what are the difference here? Because I can see that they're very different, but I could also see them playing nicely together. But what's your thoughts on that one?
So for this is so the thing is, of course, that many people these days equate AI to machine learning and specifically neural nets, or at least random forest, that kind of stuff, right? Any kind of training algorithm, right? Where you say I have a picture of a dog, and it goes through the algorithm and it says it's a dog, right? Or you give another picture and it says it's and you have that's been very successful. They've been trying to do that for 30, 40 years, whatever the case may be. But only the last years, the data was there, and it really became really, really useful, right? If you look at constraint solvers like Optaplanner, we've been around for a long time already too. And for us, the hype hasn't really started yet. And so this is why young people, to put it like this, or, some let's say people new to the AI, academic world at least would say that machine learning is AI. But in fact, AI is much more than that. And you need to use the right tool for the right job. So for example, Optaplanner cannot tell you that picture of a dog is a dog, but it can give you a great answer for a vehicle routing problem, right? If you use machine learning on a vehicle routing problem, and they have, because everybody's, TensorFlow is the new, is the solution to everything these days, right? It's terrible. They get 1% improvement. We get 15-25% improvements on speed.
Because that was my thought. Because I assume, because the thing is, some people don't realize is that what these machine learning there are today, it's basic. Well, I'm probably oversimplifying it, but it's literally just a question about having enough pre-existing data and analyzing it and finding the patterns. And similar to you about different algorithms to do the planning, they're applying different algorithms. And as far as I understand, and maybe you can tell me I'm wrong, but what the big change that happened in the last 5 years or last couple of this before they hit the success was we get way more powerful computers. They have now massive clusters. We've also optimize the algorithm to run more efficiently. But it's literally just, it's more what's it called? The law about that there's more CPU power, and they have access to more data. Like they can actually get this because they've been collecting for years. That's why the reason why Siri and Google and other the speak recognition that's working now is not because the algorithm got better. It's because they now have collected more data so they can get it right.
Yeah. It's the data. For example, for translations, they like the European Commission translates every document they write in an X number of languages. That has made in the beginning that made a really big difference in the quality of their translation algorithms. The thing is, these are all pattern recognitions, right? Again, if you want to recognize a language and translate into another, if you want a voice, and see what it's actually being saying, or an image and see that it's actually a dog being shown. All pattern recognitions, machine learning is the way to go. Absolutely. Neural nets, stuff like that. However, categorization, that's also pattern recognition. Again, look at machine learning. However, if you have a planning problem, a scheduling problem, pattern recognition is terrible. And there's a short answer for that. Humans are great at pattern recognition. If I show you a picture of anything, you'll recognize what it is, right? Humans are actually very bad at planning problems, like vehicle routing problem to traveling salesman, even the traveling. So I did a test this once with a group of engineers, traveling salesman problem, gave them a case with only 68 locations to stop. And the average was 9% off from the optimal, right? Nobody reached the optimal. And I think the best was 9%. It was quite terrible. And when you scale out, it gets worse. So and this is the typical problem. So my whole point is use the right tool for the job. There's plenty of papers that show this. Machine learning doesn't, and neural nets, they don't work on the vehicle routing problem. They don't work on the employee rostering problem.
But isn't there a way to actually combine the two? Because I could see that with some of these problems, like what you actually do to optimize it, you actually go as a human and look for patterns in how the solutions are. I was just wondering if you could actually train by just looking at enough different solver planning problems. They say, okay, so kind of use the AI to get out of the Optima problem, which I was just wondering if there are, or if there's any
research that way.
That way.
I haven't seen much yet. There might be some opportunities there. Indeed, for example, to dedicate to see we're stuck in a local optima and it's that kind of pattern, and we know how to get out of it like this. I haven't really seen them. It really involves understanding the constraints well too, right? So I haven't really seen them. What I have seen is there's two different approaches of hybrids that are very regular, right? So the simple one is where you say, not the simple one. Let me start with the most interesting one first. The most interesting one is where you say you have your data, right, and you do telemetry or something to get your data. That's called data, and then based on that you do predictions, right, with machine learning algorithms. For example, you get weather data with machine learning algorithms. You do predictions on, I would expect I can see cloud forming there and so forth. And then based upon the predictions, you do, for example, vehicle routing problem to know, for example, I will not. The moment I will install those windows in that building, it won't be raining, right? You will follow the clouds. You will stay away from the clouds while you drive your vehicles. And when you install the windows, right? Or put the roof. There's much better examples of this. So one of the example that I remember our Jim, our former CEO, once told about was like, how many red sweaters do we need to have in that store in the middle of the country, right? And that's prediction. You need to figure out how many sweaters do we need there, how many will be sold, right? At a daily rate. And once you have that prediction, you can feed that into like a vehicle routing problem in this case, to actually deliver those sweaters to that store and make sure that they can be sold there, right?
So you use So you still use Optaplanner or the planning problem as in the traditional way. It's just part of the
data comes from
the data coming in. It's coming from a result of using big data.
Machine learning. And the interesting thing is that the data can come in not just as a fixed value, like you will sell 5 sweaters. It could be more like, here's a function, a probabilistic function saying we will sell between 10 and 100 sweaters, probably 20, right? And then you can actually have your score take that into account. You can say, I want to hit there's this whole flaw of averages thing, but basically if you take the average of something, it's a dangerous thing. And sometimes you want to actually also score based upon the risk on not being the average. That's one thing. And then there's a whole other approach where you say, I'm going to do the opposite way around. I have a training problem for machine learning, and I need to hypertune the parameters. And that's where you can use Optaplanner again, or local search algorithms again. So that's a completely different area.
Oh, so you use Optaplanner to tune the training of the network.
Yeah, because the default algorithms, which most of them use, is steep descent, and that gets stuck in local optimum, right? It's usually good enough these days. The big problem here is that those trainings are too slow. So as the computer power increases and those trainings become faster, it becomes much more interesting to actually try to escape the local optimum. Right now, it takes too long anyway. So there's opportunities there. But the ones you mentioned, can we actually use it inside the algorithms? We haven't done it yet. I haven't seen it yet in research.
It's probably again. Yeah, I just wanted, but I assume for one specific case, it's probably you're gonna have not enough data. But I was just wondering for like travel salesman, the whole like that problem. Like where it's the same class of problems. I'm just wondering if there couldn't be some way to express, this is how it like just process that through the big collect all the different the ways have been done, and just kind of see which one when you start have to measure when I jump out of Optaplanner that looked like this, then it worked or it got worse, and you just iterate. I'm just wondering, but it might just be too specialized to work, but.
Could be, but one of the challenges also is there's a lot of approaches that specifically work very well for traveling salesman problem, and then they don't work for the vehicle routing problem, or they work for the vehicle routing problem, but they don't work for vehicle routing with time windows. And it turns out nobody has a vehicle routing problem clean vanilla, right? Everybody has some extra constraints in there, whether it be skills, whether it be time windows, whether it be skills and time windows.
But that's the thing that's funny. Like imagine like Amazon who's doing travel sales every day with their routing or anyone else who's actually generating a lot of data. And there is an algorithm. I'm pretty sure. Well, guaranteed there's something like Optaplanner being used behind the scenes in this. They're collecting all this kind of data, and it's the same thing that you do with the pattern recognition of the way to recognize the dog of a picture is an algorithm that's actually just been looking at the different comparisons. Like, okay, if I choose this, then I win. If I choose don't, I don't. And just have an AI doing the same thing on the algorithm who's optimizing. And then feed that in to actually go like, hey, you know what? You made this choice on Sundays, and then there's patterns that humans won't find, but the AI will because they can see the full data set. Because then the it's literally just a recognition of patterns where and this might be fault in the algorithm that the AI will find or highlight. Or it'll just be, hey, you know what? There is a trend that our constraint hasn't. That our constraints are optimized to every Sunday we don't go somewhere, but actually, if you did, because the traffic something is influenced the actual real life thing. Because then you can. I could just start seeing it. That's the same kind of problem. To do so. So you use the big data to optimize. It's just like a self. What's called? It'll feed itself.
You come into something they call hyperheuristics also, where you say, okay, I have different algorithms and I can choose between those algorithms. And what you're talking about then is that you're doing machine learning on top of the hyperheuristic. So the hyperheuristic says I have multiple algorithms and I will run them one by one and then switch between them. So now in Optaplanner you make a choice. I run this algorithm, tabu search or something like that, right? And then with hyperheuristics you can run them one by one and then switch between them. And with machine learning you can then learn on top of that hyper. Yeah, there's lots of opportunities there. There's definitely some challenges and there's a lot of research opportunities there. And then of course, once we see which of the POCs there work well, we should definitely start implementing these.
Because that's the thing is like, the way I was thinking is that if you think it's something in Optaplanner, you basically have all these constraints you expressed. And those constraints are, you're chosen by experience on knowing the domain and knowing what things we remember happened. Every Sunday we shouldn't go to these roads because they are blocked off or whatever. But the AI you could literally just have it observe it for a year or two, and then the next year you just have it evaluate. Okay, the algorithm would choose this way. But the AI is also doing the same thing. Okay, this is fine. But the next time the AI says, no, you should go the other way. Yeah. And then you can basically just try and go that way, as same as you, and literally just as a way to go out of, and it might discover that, if you actually go the way that the pattern says rather than what your constraint says, you get a better solution. But anyway, if there's just more time in the day to have all these fun stuff, but yeah. But anyway,
it sounds like an interesting experiment, something to really try.
So, but anyway, what I was the whole point is that to remind everyone who's listening that AI is not just the machine learning, the very popular NVIDIA and in the ecosystem of TensorFlow and stuff. That is definitely very powerful. It's for a very specific problem. Optaplanner and other solutions is for the planning problem, and those two are separate. It's different research, there is some overlap. There's some combinations, but they're like I'll not say yin and yang, but they're like they're the right tool for the right job kind of thing. You have to think about.
Yes, absolutely. And then for those who then claim that Optaplanner isn't really AI or constraint solving isn't really AI, this is considered the Bible of AI.
I read that one.
And it's a really thick one. And so the algorithms of Optaplanner are in there, right? So that is generally the proof saying, okay, it is also AI. It's not machine learning. Right?
Yeah, it's different.
And there's many more, right? It doesn't stop with that. There's many more. So again, right tool for the right job. Google search, for example, right? That doesn't use machine learning under the hood. That uses what is it again? The vector. What is it? Vector state, or whatever the case may be. Lucene, right? Yeah. Lucene approach, right?
Yes.
Right tool for the right job again. That's also AI.
But I think they do use machine learning. But they are actually combining the big data with, if you're that kind of, like, it looks like your past search history to see which of the answers they might want to prioritize it. That's a pattern. That's a pattern recognition issue. Yeah. So here to end off, one of the things. So in let's say the current AI, what you call the pattern matching or big data, TensorFlow and those guys are very popular. And what we're saying here is that in the planner problem, Optaplanner is probably one of the most, at least the one as far as I know, one of the more accessible ones.
Yeah.
Is there any plans? Go ahead.
Yeah, I mean, if you see, if most people most planning problems are doing manual or very in-house greedy algorithms, and we can do much better with that with Optaplanner in both cases if they're human in that case. But what I sense is that it's like, it still needs to get started. The wave still needs to get started. We have a number of competitors that are doing well too, but we have nice on Hacker News. Somebody said I think half of the implementations out there replying prompts are using Optaplanner. I'm not sure if that's true, but I like that idea.
You'll take that. If on Hacker News, it's true. That's for sure.
Yeah. But I think 90% of the cases, 95% of the cases are not using anything and any constraint solver yet.
It's not. It's what's it called?
It's not terraformed yet.
It hasn't crossed this chasm yet. It's yeah. So, but I was this is again one of the things I had a crazy when I thought about this Optaplanner, because then machine learning. Oh, sorry, let me see. Now I'm doing the same mistake. Well, yeah, machine learning cases. Python is a big language. Is there any? And I was when I look at the problem I did with the window layout, I was like, I could actually do language binding to Optaplanner from Python, because Python is you could. Well, just have that been considered to make either as a language binding, or have literally a service where you I'm saying literally a lot of times now, but being able to express these constraints in a way that hey, you know, like what TensorFlow does is like I think it's a native C library behind the scenes, but it takes the Python objects and you apply the different functions on it, and then it runs through, and out comes the result. And I was like, hey, we could actually do the same thing for Optaplanner.
I'm hoping we can. I'm waiting a bit on Truffle for that. That's one of the projects I'm waiting for that. There's a couple of projects that are going on like this, right? I saw an example where they use JavaScript to call Truffle. I think Python also to call actually in that case it was some rules and stuff like that. So
Truffle, you mean the GraalVM?
The GraalVM stuff, right?
Okay.
Yeah. Sure. That's one of my hopes. So I'm hoping basically somebody else solves the problem for me and I can reuse it.
I was just wondering, because I really like the way Optaplanner does. I just when I look, I like the approach it has. But I also see that'll be good to actually expose it to that whole ecosystem. So,
Yes, absolutely. And we regularly get requests from people using Python or .NET or whatever the case may be. Even they say, okay, I want to use Optaplanner. How can I avoid writing Java code? And then your answer is you can write Kotlin too, or you can write Scala. And then, but I want to, that doesn't really help, right?
Sure.
I guess Jython, but and so we have most of our users are Java, of course. That's our. But we do see customers using these other languages too in the JVM, and that's fine. And we even now have examples of you seen. So we make sure it runs smoothly on those languages too. As for Python, well, as long as we were waiting for the connection between the Python and JVM world to mature through, for example, Truffle Graal. And I would love to see that happening. The other approach is we expose it as a REST service, and this is again but then you still need to write your domain and your constraints in Java, right? And then everything else gets generated from Quarkus.
Well, why? Well, Again, the thing is, you don't have to. Well, I mean, I'm oversimplifying, but every time I look at how TensorFlow, the whole that is literally just number crunching, right? It's just like they have not a Haskell, a JSON object that has values on it, and then you just write a function and evaluate it, and it does its thing. And I was just, well, why couldn't we just have these things as JSON or hash maps as what you call them, the facts, right?
So for the model, yes. So the domain input, yes. You'd still need the model. You still need to know what is the thing I can change, the time slot, the room of the lesson, right?
But those are just, hey, if I look, this is this X path, like JSON path. That's where things are. I'm thinking out loud.
It's a good idea. It's something we've been thinking of, but so what you're really talking about is a full generic solver service, right?
Yes, that's
definitely one thing we're thinking of. The big challenge is we first want to build some specialized services, one for vehicle routing, one for employee rostering, to just figure out what we need to build in the generic service. If it's purely You give us a problem, we solve it, we send it back to you after a while. That's one issue. But like in the vehicle routing problem, you want to do, a vehicle calls in, is broken, an employee calls in sick. You want to react on real-time problem fact changes, right? So it becomes more complex. Yeah. It's an interesting. Yes, but give us some time.
Sure.
And then you don't need Python, but then you need to code in JSON. I would argue you would write your constraints in JSON. So I'm not sure if that's a better thing than Java. You can say it's not Java, it's JSON, right?
Sure. Anyway, okay. So anyway, we've gone on way longer than planned. So
but interesting 15 minutes.
Yes, that's 5 minutes. So let's end this today, and thank you, and sorry for all the problems yesterday. And,
thank you for hosting.
We'll do that, yeah.
Questions.
Anyway, okay. Well, thank you guys, and see you around.